This is a good example of something that would show up on a standardized test that students in elementary school are currently taking. That's actually where I got the question from, was to look at the what's called the STAR test now, but I don't want to, who knows if that's going to change. Anyway, so this is a typical question that I can't remember if it was second, third, or fourth grade would encounter, but it's right there in the middle of the elementary school grade level. Question goes, a pattern of shaded white squares is shown above. Assuming the pattern continues, how many shaded and white squares will there be in the 10th image? Okay, so talk about organizing our thoughts. What we want to do is we're going to look at this sort of two different ways. We're going to start with the shaded square and see what we notice here. So in the first picture we have one square. In the second picture we have 4 squares. In the third picture we have 9 squares. Okay. Do we notice a relationship going on? Hopefully we notice that it's every number is squared. So 1 squared, 2 squared, 3 squared to get the number of squares there. So in the 10th image, if I was to keep this chart going, then I would expect it to be 10 squared or 100 shaded squares. Okay. All right, so we'll come back and look, formalize that up here in a second. Let's talk about white squares. All right, so in the first image, I have 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 squares. In the second image, I have, let's see, 4, 8, 10, 12. Okay. Not quite sure if there's anything useful going on there, but we'll look at it. In the third image, I have 5, 10, plus another 6, so 16. All right, so let's take a look at our observation then and see what we notice. As we go from 8 to 12 and 12 to 6, ooh, we are adding 4 each time. All right, so it's an arithmetic sequence. Ooh, we have a formula for this. We have the nth term of an arithmetic sequence. A sub n is a to the first term plus n minus 1 times a common difference. So if I want the 10th term in this pattern, I want the first term, which was 8, plus n in this case is 10 minus 1, and then times the common difference. We are adding 4 each time. And then I just want to work that out. So 8 plus 9 times 4, and that would be 8 plus 36. So I can pull a calculator out for that. 8 plus, yeah, I know, 8 plus 36 is 44, but okay, so 44. Okay, so let's sum up our answer here. There are 100 shaded squares and 44 white squares. Now, we don't do this too much, but just take a second and look at the question and look at what you have to do. And that's the type of thing that you'd have to expose kids to, especially middle school or elementary school kids, just to get them to answer a question like that. So you guys are definitely in a brave occupation, and we need you. We need good, talented people like you to do stuff like this. All right, next up is understanding sets and just the symbols and symbolic logic that goes with sets. So here we have a universal set with the letters N-U-M-E-R-A-T-I-O-N, numeration. I know, cute, huh? Then we're going to define 4 other subsets. So within U, we're going to say there's the set ATE, B's got TAME, C and E are listed. E, by the way, is the empty set. Just that's what it is. All right, so for the first task is to use the notation and identify the elements within each set. Okay, so I want the union of B and C. So I want everything in B included with everything in C. So let's see. There is a T in both. Well, there's a T in, doesn't matter if it's in both. There's a T in B, there's an M, there's an M, and there's an E. And then I need to throw on anything that's also in R, in C. So there's an R in there. I already have an A, so I don't need that again. I already have a T, so I don't need that. I need an I, an O, and an N. Okay, so that would be the union of sets B and C, or the stuff in B plus anything new that happens to be in C. Number 10 is the intersection of A and B. So I'm going to look at the two sets and look at what do they have in common. So they both have A's and they both have T's, and so and they both have E's. Okay, so that's the intersection. Okay, the difference or the complement of the complement of the difference of the complement of B. Sorry, difference of the complement of B from A. Okay, so what this is formally saying, it kind of looks like a subtraction. So let's take a look at B, and what's in B that's not in A? Is there anything that's sort of extra in B? As it turns out, B has all of A in it. B has all three letters A, T, and E, but it's got an extra letter M. Okay, so the difference, the difference of the two sets would be M. I'm going to do a bonus one for you, just to talk about sort of one condition that might show up. I'm going to look at B minus C, or C minus B. I'm sorry, I said one and wrote the other. I'm going to look at C minus B. And when I'm looking at C, I can see that C has an R and B doesn't, so it still shows up in the difference there. A is in both, so A is going to go away, T is going to go away, I is not, O is not, and N is not. Okay, and so that's what's left over from C after B takes stuff away from it. Now, the question that I want you to be aware of is B also has other letters in it, but because C was the one in front, then I was looking at the difference of when I take B from C. Okay, so we don't end up with like negative letters or negative numbers. Anyways, so it's just the stuff in the elements of C once we've taken the elements of B out of C, if that makes sense. And that's what we're left with. Okay, next up is the complement. This symbol with the line on top means complement. So that means I'm going to go back to the universal set, and I'm going to identify things that are not in C, but are also that are in the universal set. So I'm just going to go letter by letter here. So I can see an N in C, so I don't want to include that. U is not in C, so it's in the complement. M is not in C. Sorry, M. Make sure I'm very clear about that. M. Let's see what else. E is not. R is. A is. T, I. So the rest of that is. Okay, so those are the only things that are in the complement of C are those three letters. In other words, C has everything else in it, but I'm looking for the things that are opposite of C or not in C. And then the last question over this particular set is cardinality. That's N, the number of elements in B. So I just go in and count the number of actual physical elements. So 1, 2, 3, 4. So there are 4 things in B. Okay, and then we have a little bit of a theory question. So this subset versus proper subset. Okay, so I guess the easiest one to address is A is a subset of B, of C. So A is a subset of C. So we're going to look A subset of C. So do I see all of A in all of C? And the answer is no. I do see an A and a T, but E is not in C. So in other words, C is got more stuff in it than A, and A's got stuff that's different than C. So they're not subsets of each other. So that's a no. A has an element that is not in C. Okay. Is E a subset of C? Is E a subset of C? Well, actually, E is the empty subset. So even though there are letters in C, when I start looking at C as different the subsets that I could break C up into, an empty set is an option. You know, you can always have nothing there. It's like C. Think of C as like a house. C's got 6 people that live in his house. Is it ever possible to have the house be empty? Sure, yeah, that's possible. Is it ever possible to have everybody there? Yeah, that's what, as parents, that's what we ideally want, is we want everyone home. Most likely, you know, people are doing their own thing. But, so is the empty set a subset of this set? The answer is yes. It's a good definition. And then 16 is a proper subset of B. Okay, that symbol means proper. Let's kind of look at A and B and look at what's going on here. So first off, does B have all of A in it? So if you look, A's got A, T, and E, B's got A, T, and E in it. So A is in fact a subset of B. The question is it proper? So proper would mean I know for a fact that there's more stuff in B than there is in A. And I can see that that E is in B and it's not in, I'm sorry, the M. The M is in B, but it's not in A. So B is a bigger set than A. So that actually is yes. Okay, again, that symbol right there, that means proper subset. Kind of like a less than or equal to. You know, A is less than B, whereas up here, you know, we had E is less than or equal to C. Sort of another way to think about this is that, you know, it's less than it or equal to it, but a proper subset, we know for a fact that B is bigger than A. How many subsets are there for A? All right, so we'll go back up to A. A has 3 elements in it. All right, so there's 3 elements in A. That's not the answer, by the way. So one thing, we have a formula that generates this. It's just 2 to the n. So there could be 8, I'm sorry, there's 8 subsets total. One way to think about this is you've got an empty set, sets with 1 in it, stuff with 2 in it, and stuff with all 3 in it. So there's 1 empty set in every set. There are 3 elements in A, so there are 3 sets that have just 1 element in it. Consequently, there's 1 set that has just all 3 of them in it. And then how many subsets would have 2 elements in it? You know, you kind of think we got 3 things, so the 3 things I think were A, T, and E. So A, T, and E, so you could have A and T and A and E and T and E. So there's 3 of those. And so if we add that all up, we should generate 8. Okay, so or you can just remember the 2 to the n formula, which probably is the quickest way to do that. But there are 8 subsets for something that's got 3 elements in it. And then the very last question here is cross product. So A cross B. So let me first copy down the stuff in A, which is A, T, and E. And then the stuff in B, up here, B is T, A, M, E. A, M, E. Okay, so the cross of those would be ordered pairs. So A and T, so I'm taking A with T, A with A with M, A with E. So I'm going to have to do that 3 times. A with A with M, A with E. Then I have T with T, T with A, T with M, T with E. And then I have E, so E with T, E with A, E with M, and E with E. And so imagine those are all ordered pairs. So there's our set of all crosses, all cross products.